Next, let's take a look at the high-low method to analyze our cost behavior. The high-low method has 3 steps that you need to follow. Step 1 is to calculate your variable cost, which is the slope of your cost line. Second step is to find the fixed cost, which is your vertical intercept. And step 3 is to create the cost equation. Now, if you have never done this before, which I know most of you haven't, you need a little bit more guidance. So I've created my own steps. So in the beginning, you can follow that. And then when you come to the exam, you'll be pros. You can remember these 3 simplified steps. So when you're doing the high-low method, the first step is they'll give you a data set. You have to find your highest volume and the lowest volume from your data set. The key is volume. You need to find the highest volume and the lowest volume of your data set. Once you have found your highest volume and lowest volume, you'll need to record your corresponding cost data for that as well. And again, we're going to work an example, but these are the steps that you would need to follow. So if you write these down, you can follow along when I do the example. Now that you have your highest volume, lowest volume, and the associated cost with it, you can calculate the slope of the cost line. The slope, if you remember, is change in cost divided by change in volume. The next step is you're going to use your cost equation to find the fixed costs, which is your vertical intercept. So once you have your slope, you can use one of the highest or the lowest volume data points to calculate your fixed costs. And then you would have your cost equation. I know this wouldn't make much sense to you, but make sure you write down these steps because we're going to do a problem next and then you will follow those steps along. We're going to use this question as an example for our high-low method. Be sure to pause the video and read the question so that you understand what they're asking for. Also, if you want to look it up in your textbook, it's on page 352 and it's a summary problem too. We're only going to tackle requirements 1 through 4. Let's look at the first requirement. The first requirement says, by looking at the total operating cost and the operating cost per member, can you explain whether the club's operating costs are variable, fixed, or mixed? So let's take a look. Let's first see if they're variable cost. As our club membership changes, does our total operating cost change? At 500 here, our total operating cost is 10,100. At 550, it's 10,150. So yes, it could be a variable cost. However, if you look at the cost per member, it is not constant, so we know that it is not a variable cost. Could it be a fixed cost? No, because for changes in volume, the total operating costs do not remain constant, so it's not a fixed cost. It is probably a mixed cost because there is an increase in total cost as your volume increases, but it's not a direct increase. It's not a proportional increase. So we assume that this is a mixed cost. Requirement 2 says to use the high-low method to determine the club's monthly operating cost equation. Now this is where you're going to use all the steps that I told you on the previous slide to calculate your cost equation. So the first step is to look at your data set, which is right here, and look at your highest volume of data and your lowest volume of data. So which of these 3 columns represent volume? It's the number of members. That is your volume. These are costs. See the dollars attached to it? Those are costs. So you're going to look at which month has the lowest volume and which month has the highest volume. Take a minute to look at them and I'll tell you soon which months had the highest and lowest volume. So step 1 says highest and lowest volume. Your highest volume was in which month? It was in November. Your highest volume was 560 members, and that we had a total operating cost of 10,500. So you're going to take 560, which is your highest volume, and then you're going to go across the column and see what was your total operating cost for that volume. For the month of November, your total operating cost was 10,500, and you need to pick that 10,500. The most common mistake that students make is they pick the highest volume on your club membership column, but then they go ahead and find the highest cost as well. You don't do that. You got to look at the cost that corresponds to your highest volume. Next, you find your lowest volume. Which one's your lowest volume? It's for the month of July, which is the 450. For the 450 members, we had a total operating cost of 8,900. Now you have all the information you need to calculate your slope. Slope again is equal to change in cost divided by change in volume. You know that your change in cost is 10,500 minus 8,900, and your change in volume is 560 minus 450. That gives you your slope to be equal to $14.55 per member. And remember, your slope is the variable cost per unit. Our next step is to find our fixed cost, or your vertical intercept. How would you do that? We have to use the cost equation for your highest or your lowest data point. This will not work if you use any other data point. You have to pick one of the two data points that we use to calculate step 1. You know that your cost equation is y equals vx plus f. If we take our highest data point to calculate the fixed cost, your highest data point said that your total cost was 10,500. Your variable cost, which you calculated in step 1, was $14.55 per member. You know that at your highest data point, the volume was 560 guests, so your x is 560. Now your only unknown is f, which is your fixed cost, and you know how to calculate that. You solve for f. That gives f to be $2,352. That's your fixed cost. If you could pause this video and you could recalculate the same information for your lowest data point. You know that your total cost was 8,900. Your variable cost per unit didn't change, it's $14.55, and your volume was 450. So calculate your fixed cost using that data point and see what you get. You should get the same 2,352 as your fixed cost. Now that you have your fixed cost, you can come up with your cost equation. Your cost equation is y equals $14.55, which is your V, variable cost per unit, multiplied by your volume, x, plus f, which is your fixed cost. In this case, we know that fixed cost is 2,352. So you got y equals 1455 x plus 2352. That is your cost equation for this particular data set. Now you can use this cost equation to predict total cost at different volumes. Requirement 3 asks that you predict the cost if you have 600 members. So they want to know what your monthly operating cost would be, which is y, if you had 600 members. So let's go ahead and calculate that next. So you have your cost equation, y equals 1455x plus 2352. And you're going to put 600 in place of x, and then you're going to solve for y. And you will have y is equal to 11,082. That completes step 3. Step 4 says, can you predict total monthly operating cost if the club has 3,000 members? Now here, they're asking about 3,000 members. Let's look at relevant range. They've given you information between 450 and 560 members. So 450 and 560, in our third requirement 3, we said for 600 members, can we use this cost equation? Yes, probably, because for 600 members, it's pretty close to 560. We're probably still within our relevant range. However, 300 members is way ahead, way more than 600, way over our relevant range, And most likely at 3,000 members, the cost equation would have completely changed. Your fixed cost would no longer be within your relevant range. Therefore, we have no way of predicting what our total cost would be if we had 3,000 members.